Welcome all. In this lecture, we will discuss about a response of system using Fourier transform. So first we can discuss impulse response of a system using Fourier transform. So consider differential equation of a system as a1 d cube by dt cube y of t, a2 d square by dt square y of t plus a3 d by dt of y of t plus a4 y of t is equal to b1 d cube by dt cube x of t plus b2 d square by dt square x of t plus b3 d by dt of x of t plus b4 x of t, where x of t is the input signal and y of t is the output signal or response. So we can take the Fourier transform on both sides. So for this we are using the property, differentiation property. We have the differential property discussed in previous lecture as Fourier transform of d raised to n by dt raised to n x of t is equal to j omega whole raised to n x of j omega. So here we will get like this. This become j omega cube into x of y of j omega. This is y of t, so y of j omega, and a2 is constant. Here it become j omega square y of j omega. Here become j omega. Here it is only 1 d raised to 1 by dt raised to 1, so j omega y of j omega. Here there is only y of t, so it become y of j omega. And here b1, here also j omega cube x of j omega. This become b2 j omega square x of j omega. This become b3, here j omega x of j omega, here only x of t, so it become b4 x of j omega. Then we can take here y of j omega common and here x of j omega common, so it become like this. Then we can find the ratio y of j omega divided by x of j omega. This become here and x of j omega here become, so this term b1 j omega cube plus b2 j omega square plus b3 j omega plus b4, denominator this one a1 j omega cube plus a2 j omega square plus a3 j omega plus a4. So this is the ratio of y of j omega by x of j omega. Y of j omega means Fourier transform of output and x of j omega means Fourier transform of input signal. And in general we have the impulse response h of t. H of t is the impulse response. If h of t is the impulse response, then response of the system for input signal x of t is given by y of t equal to x of t star h of t, the convolution. So we have discussed in previous lectures. So now we have the Fourier transform of two convolutions, x1 of t star x2 of t equal to x1 of j omega into x2 of j omega, the products of their Fourier transform. This we have discussed in the previous lecture. So by using this we can write the Fourier transform of this. Fourier transform of x of t is x of j omega and the convolution is their products x of j omega into h of j omega. So we can write as the h of omega, h of j omega. H of j omega means the Fourier transform of the impulse response will be the ratio of y of j omega by x of j omega. So impulse response will be y of h of t will be the f inverse, Fourier transform inverse of h of j omega, or Fourier transform inverse of this term y of j omega by x of j omega. But we have from previous slide, it is y of j omega by x of j omega is equal to this from the differential equation of the system. So from the differential equation of the system we can find this ratio, output by input. So this ratio will be automatically the impulse, the Fourier transform of the impulse response, and for finding the h of t we can take the inverse of this. So by partial fraction we can find the we can convert it into factors and we can take the Fourier transform inverse. Then response of a system. So we have discussed the impulse response. Then response means the general response for any input signal. So we have if h of t is the impulse response, then response of system for any signal x of t is given by y of t is equal to x of t convolution h of t. So by using the property of Fourier transform, we can write as y of j omega. The Fourier transform of y of t will be equal to x of j omega into h of j omega. So response of a system for any input x of t. X of t is the input and y of t is the response output. So y of t can be found by taking Fourier transform inverse of y of j omega. Then it will be equal to Fourier transform inverse of x of j omega into x of j omega into h of j omega, means the Fourier transform of input signal into h of j omega. But h of j omega is by the differential equation of system we can obtain like this. So from this we can find the response by multiplying this term into the input, the Fourier transform of the input, then taking inverse. Then frequency response of the system using Fourier transform. So we have the h of j omega, means the Fourier transform of the impulse response like this from the differential equation of the system. So now we can write this in by factors. We can factorize the numerator and denominator, and we can write like this. Okay, j omega plus n2, j omega plus n1, j omega plus n0. Similarly, denominator j omega plus d2, j omega plus d1, j omega plus d0. Then this is actually in terms of frequency omega. So by changing frequency we can find the h of j omega. Okay, so this is actually the frequency response, means a variation with respect to omega with frequency. So it is actually the frequency response. So we can find the frequency response, the magnitude means the magnitude of this, means this is in the term a plus jb. So it is root of a square plus b square. So it become in numerator omega square plus, here b is omega, a is n2. So omega square plus n2 square into omega square plus n1 square, omega square plus n0 square, that root of this. Similarly, denominator root of omega square plus d2 square, omega square plus d1 square into omega square plus d0 square. So by doing this we'll get the magnitude of frequency response, and phase means the angle of this. So angle of this means we can find, this is in the term a plus jb. So the angle is tan inverse b by a. So it is tan inverse, numerator we have to take plus. So plus tan inverse omega by n2, here plus tan inverse omega by n1, here plus tan inverse omega by n0, and denominator we have to take minus. So minus tan inverse omega by d2, here minus tan inverse omega by d1, here minus tan inverse omega by d0. So by doing this we will get the frequency response in both magnitude and phase. And we can also plot the magnitude and phase by taking different values for omega and plotting h of j omega, magnitude and angle. So with this we can wind up the session. Thank you.